This video will demonstrate trust execution environments integration in the EDGELESS system by leveraging EDGELESS methodologies. During this demonstration, we will use three machines. On the left, we have a dedicated machine incorporating the eController, eOrchestrator, and the CLI. The CLI will interact with the system to assign workflows. In the middle, we have the first node. Node 1 has EDGELESS capabilities and will execute a trusted version of the EDGELESS node code inside an enclave. On the right, we have another node, without specialized hardware. The process we will follow includes the following steps. First, the deployment of the eController and eOrchestrator. Next, we will register the two nodes into the system. Finally, we will assign workflows from the CLI and ensure that functions requiring execution int s, based on the given annotations, are dispatched to the appropriate node and executed inside an enclave. To begin, we will first make sure that Node 1 supports SGX. As we can see, Node 1 runs on an Intel NUC device, a small form factor machine with limited capabilities similar to the type of device the EDGELESS platform targets, and it also supports SGX. During this demo, we will utilize SecureExecutor tool. SecureExecutor was developed to simplify the process of building and running a confidential version of the binary of the EDGELESS node. At this point, the trusted binary of the EDGELESS node is not available in the current directory. However, when we execute the build command, a new directory entitled EDGELESS_node will be appeared, containing everything we need. Inside the generated folder is the trust binary, Node's default configuration file, and an auxiliary script. This script will help us assign the proper IP addresses for our demonstration. We will run the helper script and pass the eOrchestrator's IP as an argument. Then, if we inspect the configuration, we can ensure that the correct IP addresses are set and that TS support annotation is enabled for this node. For completeness, we can also verify that Node 2 does not support TS. Since we now have both the binaries and nodes configuration files, we are ready to establish a connection among all these system components. First, let's deploy eController. Then, eOrchestrator. Now, let's start Node 2, which does not have a specialized hardware. Node 2 is running directly on the main memory, without security guarantees. For Node 1, we will once again utilize SecureExecutor to start the binary. As we can see from the log messages, Node 1 is running in SGX debug mode inside an enclave, and we can also find available enclave's hash. Now we are ready to start some workflows. We will run two workflows, each containing only one function, specifically the no-op example. They differ in the annotations that each one has inside its configuration. The workflows' names are no-op and no-op-te. First, let's examine the JSON file for the no-op-te workflow. The no-op-te workflow requires its function to be executed inside an enclave. Unlike this, we do not have that kind of limitation for the no-op workflow. Now, let's run the workflow which does not require TE. When we assign this workflow, we should expect Node 2 to execute the function. As we can see, this is verified. Now, let's start the no-op-te workflow to evaluate whether it will be dispatched to Node 1 and its function will be executed inside a TE. As you can see, this is also true. If we list the workflows, there are indeed two. The last step of the demonstration is to stop both workflows and ensure that nothing is running in the background.